And good evening and greetings to the rest of the folks. So we'll go ahead and get started here. And before I get started, now I hope by now you did get a chance to go ahead and review some of our earlier demo sessions. But what I will do is I will go ahead and quickly introduce myself one more time, and then we'll get started, guys. Okay. So that's a brief introduction. My name is Naveen. I have about 18 years experience in IT, ladies and gentlemen, and about 10 years I lived in US, and about last 7 to 8 years I'm here in India, and last 2 to 3 years I've been heavily involved in the big data and the data science platforms and technologies, guys. So that's a brief introduction about myself. So the plan for today is we're going to cover module 1, which is going to be, let me put it now, which are going to be these topics, guys. We'll once again have a quick look at what is big data and Hadoop in the interest of those who may have missed the demo, or in the interest of just making sure we understand these concepts. We'll try to understand the challenges and the technologies which are supporting, and how Hadoop comes to our rescue and how it helps us, and why it is important to use Hadoop and the rest of the components of it. And we'll also try to move on to HDFS and MapReduce today and tomorrow, guys. Okay. So this is going to be our module 1, guys. Before I move on to module 1, let me just go ahead and give a quick have a quick look at our course content. So this is what I intend to cover today and tomorrow in module 1 and module 2, which is about the big data and Hadoop, and tomorrow we'll go over understanding cluster architecture and the MapReduce, guys. And the following week we'll go ahead and get into MapReduce and advanced MapReduce concepts. We will also discuss yarn and planning the cluster. And then the third week we'll get into Apache Pig, the module 1, and then followed by Hive, which is going to be module 6. Then we'll move on to HBase, Sqoop, and Flume and Uzi in the 4th and the 5th weeks. And the final project that we're going to be doing is going to be in the banking POC, guys. I have given some information about this in our demo. You can also refer to that one for more information on that. And towards the end of the course, we'll go ahead and have a look at our Apache Spark and Scala. This is one of those things which is receiving a little bit of it, actually a good amount of attention, and it will be helpful for you guys if you have an idea and about Spark and Scala, guys. Okay, so that's going to be the complete plan. By now, Chandra might have shared the module 1, module 2, and the details about these modules, what we will be going over, and other stuff. So that's a detailed look. If you haven't received this one from Chandra, please feel free to let him know. He will help you guys in he will help you and with any other further questions and things like that, guys. Okay. So let's come back here. So gentlemen and ladies, the way we will proceed is as I make progress here, I will be asking you to just go ahead and I will try to make sure that you are with me, you're following with me, and we are in sync with each other. So I will ask you to just go ahead and type in the questions window, whether you're following on me or not, and things like that. At any point of time, if you get any questions and things like that, you can type in the questions window, guys. Okay. And whenever I ask you, it will be nice if you can just go ahead and type in a Y or a no, or you can ask me to repeat at any point if you do not understand anything at any point, guys. Okay, I'll stop there. I'll try to address your questions. Here and there, I may proceed even though there are questions coming in, and do not worry. What I will try to do is I will try to kind of take a logical break at the point, and then I will go ahead and answer your questions. Okay, so that's about myself, guys. So what we will do today here is let me go ahead and first introduce yourselves, have you introduce yourself briefly. You can just say your name, where you're located, and what motivated you, or your objective in learning Hadoop is what you can share. We don't have many people here, so please feel free to share any other questions you may have. Once that is done, we'll spend about 5 to 10 minutes on that. We'll get started with today's topics, guys, okay? So I have Anya Voru on the top. Let's start with Anya, guys, okay? Anya, you're unmuted now. You can go ahead and introduce yourself.
Sure, Naveen. So basically, I'm located in London. I'm an IT consultant purely into data warehouse. And I've been in this industry, in this domain for almost I do understand that big data and Hadoop, all these are going to be the next big thing that's going to happen. So,
Wonderful, wonderful, Anya. That is a very good thing that you're in a great location, London. That sounds really great, and you're in data warehouse. That is a field to be in today, because everybody who are in data warehouse, every company are the first guys to look at big data and Hadoop, and that is where Hadoop you will see the magic of Hadoop and things like that. Okay, so I appreciate that, Anya. Any questions before I move on, Anya?
Not really, no.
Okay, great. Thank you, Anya. Appreciate that again. And let's move on to Chandrasekhar here. Chandra, you're on.
Yeah, good morning, guys. Good evening, guys. My name is Chandrasekhar. I've been working in the IT industry since 10 years. Basically, I'm working on the middleware technologies like WebLogic, WebSphere, and all those. I'm trying to concentrate on this Hadoop technology. I want to learn many concepts in this because it is an emerging technology. Want to get some knowledge on this, and I want to move to Hadoop also. That is where I'm concentrating on.
Very good, Chandra. And you said you are into data warehousing.
I'm not. I'm in the middleware technologies, middleware and operating system.
I see, I see. So what tools you use, Chandra?
Almost all many tools like WebLogic, WebSphere, JBoss, and like Tomcat and everything.
Okay, okay, very good. So you're in the world of Java. For a moment, I thought you might be familiar with BizTalk also, but I guess you are familiar. You are in the Java world. Okay, so that's. Go ahead,
Yeah,
Chandra.
basically I'm not in the Java. I'm in the middleware technologies. Like Java will be using in between that, but we don't know much about the Java.
Gotcha.
We can understand.
Gotcha. So what I meant was, I mean, WebSphere, WebLogic, all these are in the world of Java, not in the world of .NET and things like that. So that's good, Chandra. Appreciate it. And where are you located, Chandra?
I'm staying in Hyderabad itself.
Very good. All right. Sounds good, Chandra. Appreciate it again. We'll move on here to Sunil. See how he's doing. Sunil, you're on air, buddy. Sunil, are you able to talk? So no problem. What we'll do is we'll come back here to Sunil later and we'll try to see if he's in a better position to introduce himself, guys. Okay. So if you give me one acknowledgement, we'll go ahead and get started with our content, guys. Okay. Can you quickly type in a Y in the questions window? And we'll go ahead and get started here. Cool, great. All right, gentlemen, so some of the concepts I may have covered in the demo, but I'm going to go ahead and quickly review them. And let's start with big data. Okay, big data, there is a problem and things like that, guys. Let's try to get a feel of the problem. And let me take a snap here. Cool. So, gentlemen, ladies, big data is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable amount of elapsed time. That is what big data is, guys. Okay. So what that means is, let's say you have a laptop, gentlemen. Okay, and that's your laptop, and let's say you have about 1 GB of data. That's your 1 GB of data. Let's go ahead. It's 1 GB of data. Cool. And what we would like to do is we want to go ahead and put that 1 GB of data into a laptop, and then we may want to write a Java program. Oops. Go here. we may want to write a Java program. We can definitely process 1 GB of data generally, or we may wish to write a .NET program and process that 1 GB of data, guys. Okay. Do you think I can call 1 GB of data big data, guys? Cool. Is it a tough question? All right. So let us see when we can call it and when we cannot. Not really, says Anya. Good, Anya. Okay. It's not really big data, but here is the deal, Anya. Let us say I have this 1 GB of data that we are processing, and it is taking about 10 hours of time for me to process this 1 GB of data. But I want that to be processed in 1 hour. Do you think I can call it as big data? Cool. Let us try to understand that. Okay. So Chandra, you are muted, buddy. It's because as long as I continue, I will keep you guys unmuted. You can type in the questions window if you have any questions, and we'll try to take it like that. Okay. So let me know if you have any other things. Thank you, Chandra. Appreciate that. All right. So, gentlemen, we have 1 GB of data. We have written the Java program. We have written a .NET program. It works fine. Okay. But here is the deal. Let us say I come back here and I give you 100 terabytes of data. Okay. What do we want to do? Well, we want to go ahead and process that 100 terabytes of data. So what do? Well, we have to go ahead. If you try to put it into one laptop, it may not be enough. Even if you were to buy a server, it may have its own limits. 100 terabytes is huge data, and you will not be able to process it, guys. Okay. So let's say, generally, what do companies do? Well, what they do is they will go ahead and they will take this 100 terabytes of data, put it into multiple servers, guys. Okay. So those are the multiple servers. To put this into 100 terabytes, guys, what they will do is they will go ahead and first split this. Oops. I'll keep that. They will split this into the orders of, let's say, for sake of simplicity, we bought 100 servers, and in each servers, we want to maintain about 1 terabyte of data. So let's go ahead and say that is 1 terabyte of data. And we'll put 1 terabyte here, 1 terabyte here, and assuming we have 100 servers, we have put 100 terabytes of data, guys. Okay, gentlemen and ladies, what do you want to do once you store the data? Well, we want to go ahead and process the data, right? So let's go ahead and assume that's a 1 terabyte there, 1 terabyte there, and so on. And so on up to 100 terabytes. For sake of simplicity, we have split them and we have distributed them into different things. So now what will happen is you want to write a program. So what will you do? Well, you need to understand how these multi-nodes communicate with each other. You need to understand how the multi-process communication works. You need to understand how the multi-threading works. You need to understand how the networking works. You need to understand what happens if this goes down, what happens to your program, what happens to your data. What is that? That is fault tolerance. So you also need to understand what is called replication and other things. What does that mean, guys? Well, if you want to drive a car, what do? We turn the key. What happens inside the car? Well, your fuel is getting converted to electricity. Okay, but you don't have to be a mechanical engineer to drive a car. What is happening here? This is, to work on this data, you need to be an expert in all these complex concepts, guys. Okay, so what does that mean? To drive a car, you need to be a mechanical engineer. What is that? That's a problem. What is the problem with big data? That is the problem, guys. Okay, so if you want to drive a car, we don't have to be a mechanical engineer in real world, right? So that is what the problem that the big data is creating. Am I making sense, guys? Can you give me a quick acknowledgement? Are you with me so far? I'll take up your questions in a bit here. Cool, great. And okay, so that is the first part of it. And now, if you go back to our demo, guys, I have earlier indicated. What did I indicate? Well, we have indicated that if from, assuming this is the entire timeline of the mankind, and this is where the mankind has started digitizing the documents, And if you take up to 2003, okay, what is happening? Well, the amount of data that was generated during this time frame, okay, is supposed to be about 5 exabytes, guys. That is the amount of data that the mankind has generated from the beginning of the mankind till 2003. What happens in 2012? Somewhere here in 2012, just in 1 year, guys, okay, what happened was we have generated up to 2.7 zettabytes of data. This is what we have looked at, and we looked in slight detail, and I would encourage you to go ahead and have another look at it to understand this perspective, guys. Okay, if you compare the 2.7 zettabytes, by now you may already have an idea, how much a terabyte is, right? So there's a terabyte that equals to 1000 GB, and then comes a petabyte which equals to 1000 terabytes, and then comes 1 exabyte which equals to 1000 petabytes, guys. And then comes 1 zettabyte which equals to 1000 exabytes. Okay, so what is happening is, if you compare this one with this one, okay, so let me see if I can go ahead and put it in this part of the screen. If this dot were to be 5 exabytes, that is the amount of data that the entire mankind has generated during this deadline, guys. I'm sorry, during this timeline. Just in the year 2012, we have generated that amount of data. Okay, so that is what we are looking at, guys. This is what the entire mankind has generated. This is what the mankind has generated during just in 1 year. And if you compare this one with this one, what we are looking at is a very, very huge volume, guys. An exponential volume of data is what we are looking at. Okay, it seems 5 exabytes of data is getting generated every 2 days right from the year 2012. This is 2012. Every 2 days we are generating the total amount of data that the mankind has generated, guys. Okay, so fundamentally what are we looking at, gentlemen and ladies? We're looking at what is called the volume. The volume that we are dealing with is not double, not triple, but it is exponentially huge. That is the fundamental reference or fundamental aspect of the big data that we are looking at, guys. Okay, and gentlemen, when we say every 2 days we are generating that amount of data, what does that mean? The rate, the speed at which we are generating the data is also exponentially huge, guys. Okay, so the second aspect of the big data is velocity. All right, and when we are talking about this data, gentlemen, what is this data and why is it important? Well, today again I have discussed this aspect in my earlier demo session, guys, so I will give you a quick idea about that. Okay, what is happening today is, let me go ahead and do a little bit of clearing here. Come back here. Assuming this is our data, guys, okay, what we have is, we maintain generally in a web application or an entire application or what you call as a service-oriented architecture or other kinds of architectures, you would have a database here, right? This is your database, and this is what you call your data access layer. This is what you call the business logic layer, and then you'll have what is called a service layer, and then you'll have a UI layer, guys. Okay, what happens is, we retrieve the data from the database, we give it to the data access layer, we build some data objects, give it to the business layer, we retrieve the data from business layer, we apply some business rules in the business layer, then we give the data to the service layer, and then in the service layer you verify the authentications and authorizations and give it to your UI layer. In the UI layer, whenever users look at their reports of their applications, right, what do they get, guys? They get insights, right? What is an example of insights? So let us say they're looking at a UI screen or a UI window which is telling, hey, we're in a retail, assuming we're in looking at a retail related application. The application is indicating during the weekends most of the sales are happening by the age groups between, let's say, 10 and 20. What does that mean? Well, what that means is the teenagers are making the most of the purchases during the weekends. That is what is the insights, guys. From the insights, what do companies do? Well, they'll make a decision. They'll come up with some decisions. What is that? Well, let's say the decision is, let's offer 10% discount, okay, for the coming weekends for those age groups who are in the range of 10 to 20. So that they can make more purchases and that brings in more revenue, okay? So that is what is happening here. They're drawing insights from their database, guys, okay? What's happening today? There's a new database, gentlemen and ladies. Okay, what is that? That's your internet. Internet is becoming another source of data. Cool. And what do we have on our internet? Well, we have various kinds of sites, guys, okay? We have Facebook, we have LinkedIn, we have Twitter, we have other social networking sites. And what do companies want to do? They want to get these insights from here. They want to understand what people are talking about their products, about their companies, about are they happy, are they not happy, how the sentiment is looking. That is called sentimental analysis, guys, okay? Based on those sentiments, they want to come up with some useful decisions which will help their company, okay? What's happening on the internet? There's a problem. The problem is Facebook exposes their data, let's say, in the form of XML. And you have LinkedIn, let's say it's using some other format, and then I know Twitter exposes their data in the form of JSON, and you have other social networking sites who are exposing in some other formats. Okay, I'll just put it like that. Some other formats they are putting. Okay, so what is happening here? When you're retrieving your data from database into your UI layer, guys, these are all a simple Java application where you know everything about your data. Okay, let's say you have a table in the database, guys. What will happen? Well, you know the parent, you know the child, relationship, constraints, and everything. That is called the schema. But in the about the data on the internet, you do not know how your data looks like. You do not know the parents, child relationship, or constraints, or anything. That is called unstructured data, guys, okay? If you do not know the schema, it is called unstructured data, all right? And what companies want to do, if they write applications, they will have to write one application for XML, another one for JSON, another one for other varieties. It becomes very, very complex, guys. What are all these things? Those are the variety aspect of it. On the internet, you have different varieties of data. You have logs, you have videos, you have audios, and things like that. So that is the third aspect of big data, guys, okay? Am I making sense, guys? Can you give me a quick acknowledgement, please? Cool. Okay, great. Thank you. You can just type in a Y there, and you know, just in case that's a little help. So that is about the big data, guys, okay? Another look at big data. Just adjust my screen here. Cool. So those are the different sources, guys. You have weblogs, you have, you know, everybody's uploading their information, their sensor data and social networks, social data, and things like that. This is what is referred as a variety of the data. As the variety of the data increases, the complexity is increasing, guys, okay? Take a look at this graph. What we are saying is, as the variety is increasing, the complexity is increasing. That is what we're indicating. And as the volume of the data is increasing, the complexity of the coding is increasing, guys. Why? Because you need to be an expert in many, many concepts such as multi-node, process, threading, and all these things, okay? And one other thing, guys, big data is a combination of transactions. Transactions refers to your data in the databases and things like that, guys, okay? And interactions. Interactions is what you are casually interacting on the internet. You know, you might be saying, hey, you know what, I purchased a Samsung phone. I'm liking it. I'm really liking it. Or, you know, you might say, you know, I purchased that phone. I'm not really liking it. The casual interactions that we are making, what is happening behind the scenes, guys, is the companies are interested in detecting the sentiment. They want to understand whether the customers are happy or not. And if they're unhappy, if they're happy, nothing to worry. But if they're unhappy, they want to understand what is the problem customer is having, so that they can do something about it and they can win the customer. That's what the interactions is about, guys, okay? And observations, the log files and things like that. Every time you move from one location to another location, right, with your cell phone, what happens is your latitude and longitudes are getting transmitted to the central towers of the telecommunications towers, and those are getting logged. That kind of data gets logged in what is called log files and things like that, okay? And whenever you're entering any data on Facebook or other sites, that data is called the user generated data, guys, okay? What is happening behind the scenes? Well, as the users are entering the data, there's a lot of data which is getting logged in the log files. What is that? That is what we call as the observations, guys, okay? So that is about this one, guys. As the volume is increasing and as the data, as the variety is increasing, right, the complexity of the coding is increasing. So that's another perspective of big data, guys, okay? Making sense, guys? Are you with me? Can you give me a quick acknowledgement, please? Shall I move on to the next slide? Cool, great. All right, thanks, guys, okay? So why big data? Again, we are generating more data than ever, guys, as indicated, just remember the dot, how much data we are generating every 2 days, and these are some of the domains and other sources of the data, financial transactions, sensor networks, and application logs, your email messages, and so on, guys, okay? So another aspect is we are generating more data faster than ever. Why? Because of ubiquitous internet connectivity, guys, okay? What does that mean? Today, almost everyone in the world is trying to get onto Facebook, Twitter, and other sites on the internet, guys, okay? Why do they want to do? Because they want to share. They want to share something is good, something is, not good, and things like that. As they share, that brings some happiness to them. They would like to communicate, they would like to stay in touch with their friends and things like that. And how is that happening? Because of the internet, everybody is getting, and that is what we mean by ubiquitous internet connectivity, guys, okay? The data that a user enters is referred. One second, guys, give me a minute here. My apologies about the pause, guys. So let me come back here. So, gentlemen, ladies, the data that we are entering on any of the sites on computer is referred as a user-generated data, guys, okay? As we are entering any data, behind the scenes, the servers are logging a lot of data. What is that? That is referred as a machine-generated data. This can also be the CC cameras data, the videos and things like that. Could also be referred as the machine-generated data because the machines are generated, guys, okay? And gentlemen and ladies, let me also go ahead and explain something here, guys. This is, for a moment, let's assume that is our internet that I have earlier referred to. And for a moment, let us assume this is our database, guys, okay? What do we have? Well, we have, let us for a moment assume this is our application. And what I have indicated just now in our previous slide is today, most of the companies go to their database, they get the data, they draw insights of their, they draw insights from their application by getting the data from the database, guys, okay? The data in the database is referred as the structured data, guys, okay? So let me go ahead and put it like that. That is structured data, okay? But the data that is there on the internet is unstructured data, guys, okay? And structured data is something, go ahead and, that is unstructured data, guys, okay? Structured data is something where you know the schema, okay? And you know when you have a table, you know the entire thing about the table, so you can, so that is referred as structured data. Whereas the data on the internet, you do not know anything about it. That's called unstructured data, guys, okay? What is happening today is these are the companies, okay? They want to go here, oops, they want to go here, they want to get the data from here. But you can kind of think of it like, guys, this structured data of the database is like the rivers in the world, whereas the internet, data on the internet is like the seas and the oceans, guys, okay? What is happening? Companies, when they draw insights, what do we mean by that? Well, they want to go to this river, they want to get the fish. That is what they want to do, gentlemen, okay? So if you are able to find fish in rivers, just imagine how much of fish you can find in seas and oceans. What does that mean? Well, that is unstructured data, guys. Most of the data today is in the form of unstructured data. About 80 to 90% of the data is in the form of unstructured data, guys, okay? And structured data is just about 10 to 20% is what it is, all right? So having said that, that's a little bit, let's move on here. An example of, why we are generating a lot of data. Twitter, they're generating about 340 million messages every day. Facebook, about 2.7 billion comments and likes, okay? Really, really huge, guys, okay? And the Large Hadron Collider produces about 68 terabytes of data, guys, okay? I do not know if you followed the news, if you have a little bit of interest on physics and things like that, guys. LHC, the Large Hadron Collider, they said they have discovered what is called a God particle, apart from the protons, neutrons, electrons that we have learned during our schooling time, right? They have also detected or discovered something called a God particle, and there is more research being done, okay? A few months back, or maybe a year back, this came into a lot of, a lot of people were talking about this experiment, whether it is good or not, and this was conducted somewhere in Europe, is what it is, guys, okay? So that generates 68 terabytes of data is the message here. That is what all this again contributes to the big data, guys, okay? So am I making sense, guys? Can you give me a quick acknowledgement, please? Are you with me? Shall I move on to the next one? Very good. Thanks, guys. So let's move on here. So that is our unstructured data and structured data, guys, okay? So if I come back here, unstructured data, you do not know the schema. That is the seas and oceans, guys. And structured data, that's your database data. You know everything about your data, so it's much simpler to go ahead and write your application and work on structured data. The problem with unstructured data, a lot of challenge. It's very, very huge. If you want to analyze and if you want to extract meaningful information, which is the insights, guys, what will happen? Well, you will end up learning multi-node, multi-process, and threading and all those concepts, okay? What does that mean? To drive a car, you need to be a mechanical engineer. That doesn't make sense, guys. So that is the problem with the unstructured data. Is what it is, all right? As we move on, traditionally, so what were people doing before, okay, is this one, guys. What they would use is, if they have big data, they will buy a powerful server. Let's go here. They will buy a powerful server. They will try to dump the data onto the powerful server. They will add more hard drive, more RAM, and more processors. But the problem with the powerful server is they're expensive. And they are limited, guys. You cannot keep on adding. And let's say you added about 10 terabytes or 100 terabytes. What if you get another 100 terabytes? Well, it might not be enough. That is the problem, guys. That is the problem with the traditional approach, okay? Challenges. You cannot, capturing is one problem, capturing or storing. And then, again, if you want to, even if you're able to put 100 or 200 terabytes on a server, or even if you use 2 or 3 servers, right? You need to process the data. Again, you'll need to be a mechanical engineer to drive a car. All those concepts, very few people around the world are familiar with all those concepts, such as threading, processing, and other things, guys. They're not only complex, they're time-consuming, and they're very complex, to be frank, guys. Okay, so processing is the problem. Analyzing them, again, nothing but the same concepts. You need to be an expert. Okay, so you have to be a mechanical engineer to drive your car. That is not really meaningful, guys. Okay, so these are some of the problems, and traditional systems cannot scale. Okay, gentlemen, ladies, let's try to understand that one. Let us say this is your database, guys. Okay, let's say you have a database, and let's say you're processing some data here. Let's assume that is our data. Cool, that's my data. Here's a different one. That's my data, which is on the database. And what are we doing? We have written some kind of store procedure or some scripts. All right, and the scripts run on the data, and they generate. Let's say they're taking about 10 hours. Cool. Let's go ahead and say they're taking about 10 hours to process that data. So what we decided was, in a traditional world, let us go ahead and say we think we'll use 2 databases to reduce the amount of time. Okay. Now what do? Well, we'll take this data, we'll split this data. We'll put half here, we'll take another half. Okay. and we'll put it here. Now we have split the data, we have distributed the data. Then what do we want to do? We want to go ahead and run the code on both the databases at a time. Okay? Your amount of time, guys, should reduce logically, but that will not happen. Okay? In traditional world, as you increase the number of your servers, your computation time is not guaranteed to reduce, guys. Okay? Whereas in the world of Hadoop, that is exactly what is happening. As you increase the number of nodes, your computation time decreases, guys. Okay? As you increase your nodes, your processing power increases and your computation time decreases, guys. Okay? And so that is what. And one more thing, guys. In traditional world, the traditional systems use what is called enterprise class servers. These are all your databases and things like that are enterprise class servers, guys. Okay? These are enterprise class servers. Okay? And enterprise class servers are very expensive. Okay? That's another big problem there. In the world of Hadoop, we use what is called commodity hardware, guys. Okay? Commodity hardware is much reasonable compared to the enterprise hardware. All right? So that is what we mean by they cannot scale. That means as you increase your number of nodes in traditional world, the complexity of the coding increases, the price increases, the time is not guaranteed. Those are all the problems. They are not reliable. And suddenly, if something goes down, you're at a complete loss of your data. You have to do a lot of maintenance and things like that to bring back your server or deal with it. Okay, that is what we mean by not reliable. And they're expensive. They are about that, guys. Okay, it looks like there was something to do with the webinar, so I'll put the blame on that. It's not that I don't want to take the blame, but it appears to be. It said the audio connection is now restored. Again, my apologies, guys. So, gentlemen, ladies, I'll back up a couple of minutes what I was saying. Okay, what I was saying was at about 1.5 hours, which is approximately at about 9 a.m., we'll take a 10-minute break and we'll regroup so that we can have a glass of water or just kind of stretch ourselves and be back in. Okay, everybody okay with me, guys, on that? And just to make sure where I was, guys, okay, I do not know when I lost my audio here, but I was explaining about the enterprise class servers and commodity hardware. Were you there at that time? Did you understand that point of that? Commodity hardware. Okay, great. Thank you, guys. Okay, so as we go on, if at any point of time you lose my audio and things like that, just quickly try to indicate me, guys. I'll try to be as productive as possible during such times and not make too much progress. So just kind of give me a little bit of this thing, notice on that, okay? All right, gentlemen. So the big data, those are the problems, guys. So what is the solution? Well, that is the solution. Hadoop is the solution, okay? It is a software framework, guys. What is a framework? A framework is like an engine. What will it do? Well, when you turn the key of your car, your fuel is getting converted to electricity, guys. Okay, what's the car doing? Car has an engine, car has a framework. It's taking care of the complex things. A very sophisticated mechanical engineering thing is what is happening inside your car. But as a driver of your car, you don't need to worry about it. It's hidden from you. It is abstracted from you, guys. Okay, that's what a framework is. Okay, Hadoop, okay, will take care of all the multi-node communication, multi-thread, process, networking, replication, fault tolerance, and all that for you. What does that mean? Just if you want to drive the car, turn the key. You don't have to be a mechanical engineer. Okay, that's what the software framework refers to. It supports data-intensive distributed applications, guys. Okay, data-intensive. We are looking at very, very big data. Okay, remember, guys, when I started earlier, I have indicated, I was asking you guys, you know, if I have only 1 GB of data and I put it on a laptop and it takes 10 hours, it takes 10 hours, okay? Then I asked you, if I want it in 1 hour, would you consider 1 GB as big data, okay? I think I did not reply to that. What I'm trying to get here is that will be big data, guys, okay? So short and sweet. Let's come back here. Let's go ahead and clear this. There's my laptop, and there is my data. Cool. That is only 1 GB, but it takes 10 hours to process the data, but I want it in 1 hour. That can also be treated as big data, guys. Okay, it is beyond the ability of my software tool and hardware to process that amount of data in the tolerable amount of elapsed time. So that's another perspective of big data. We just I realized I did not answer that question. Okay, and data intensive. That's what made me reminded. Generally, in the world of big data, you don't deal with small data. You generally end up dealing with very huge data, and that's what we mean data intensive application, guys. Okay, if you see, our data is distributed, guys. Okay, so let's come back here. Let's see what the distributed means. Imagine, let's go here. Imagine this is your cluster, guys. Okay, what is a cluster? A cluster is a group of computers to start with. Okay, so these are a group of servers is what you can think, and you can assume you have something like a 100 MB file here, guys. Okay, let's assume this is a 100 MB file. Cool. Let's go ahead and select that. Let's move it up a little bit. And now we want to go ahead and put this into Hadoop, guys. Okay, so there will be a few things that Hadoop will do. What Hadoop will do is Hadoop will go ahead and split this data. Let's assume it, and it splits it in the orders of 64 megabytes. So that 100 MB will be, there's the first 64 megabytes, and let's assume that is the next 36 megabytes. Okay, a smaller one. And let's go here. That's about 64 megabytes. Let's come back here. That's about 36 megabytes, guys. Okay. Next, what will it do? Well, this is the process of splitting, guys. Let me just select this one. And next, it will go ahead and distribute the data. Good question, Anya. Why 64 megabytes? Okay. So generally, internally, if you take the native operating file systems, what is happening is internally the same kind of splitting is happening, but we are not aware of that. Okay, the native operating systems will go and split the data in 4 KB or 8 KB and things like that. So if you really read, when you read one file, we are internally opening a lot of very, very small files, and then we are reading it as one file. Okay, so the disadvantages, if you take a 64 megabytes file, you know, internally, if you imagine the number of 4 KBs or 8 KBs it becomes, right? Internally, that's a lot of processing happening, a lot of reading and writing happening internally. We do not know, we do not have to worry about it. So what they did was to improve the performance. In Hadoop, they went ahead and they have chosen a block size of 64 megabytes. So at any point of time, if we go ahead and give it a file, it is capable of, it will by default save it in the order of 64 megabytes, and when you try to read it, you are not opening too many files which are too small. You are opening only one file, which will be a bit faster, and it is a much more better resource utilization on your hardware also on here. Okay, slightly involved, slightly deep, but that is the background of that. Okay, I hope I'm making sense. Huh? Thank you. All right, so we have split it. Next, what will happen is this will be distributed, guys. Okay, so this will go into one, and this will go into another node, and then this is called the step of distribution, guys. Then what will happen is your replication will happen. Okay, so here this one will be taken, and it will get replicated there, and it will also get replicated there, and this one will get replicated here. Replicated means an additional copy of your block is being made on other nodes, guys. Okay, all these things are being done by Hadoop. We don't worry about that. What is this? Notice your data is distributed in multiple nodes here, and it is also replicated. What is this? This is a data intensive distributed application. Okay, so it's a framework, it's an engine, it's data intensive. We deal with big data, we really deal with huge volumes of data. It's a distributed application. Why? Well, that's how it works. And gentlemen, ladies, the important thing is when the process of splitting is happening, right? when this process of splitting is happening, when the process of distribution is happening, when the process of replication is happening, what's happening? Multi-node, multi-process, multi-threading, networking, fault tolerance, replication. All those things are happening. Who's taking care of that? That's our Hadoop. And even better thing is it's free, guys, okay? So that is what the Hadoop is doing. It enables applications to work with thousands of nodes and petabytes of data. So what does that mean? Well, let's say you have a laptop and you write, you put this 100 MB, okay? Let's say this is our laptop. There's my laptop. We'll put this 100 MB onto our laptop. And now let's assume we go ahead and write a Java MapReduce program, or Java MapReduce, or any kind of Hadoop program for a moment, okay? If you write this program, guys, when we write this program, and if it successfully works on this 100 MB of data, go ahead and run this program on a 100 node cluster or 1000 node cluster. We will not make a single code change here in our program. That is the usefulness and the magic of Hadoop, guys, okay? Am I making sense, guys? That is what we mean by it enables applications to work with thousands of nodes and petabytes of data. So your code is independent of the size of the data, guys, okay? And it was inspired by Google's MapReduce and Google file system. What do we mean by that? Well, you might be wondering, well, Google actually has been using these concepts about 15 years back, or some 15 or maybe 20 years back, guys. Actually, in 1996 and things like that itself, they started using these things. We are learning them today, okay? You might be wondering, or if I were to ask you, why should we learn what Google has done today, okay? If that question comes to you, here is the answer, guys. The reason is Google has become successful. By learning this kind of concepts and frameworks, right, we can go back to our own organizations and we can help them in being successful. Cool? Gentlemen, ladies, everybody okay with this slide? Any questions on this slide? Shall I move to the next slide? Great. Thank you, guys. Okay, so what is Hadoop? Well, Hadoop is providing us a framework of tools. What's the framework of tools? Well, let me come back and, okay, so to understand the framework of tools, guys, let us come back here, okay, and let's go down like this. Hadoop is fundamentally a distributed file system, guys, okay. What's a distributed file system? A distributed file system is nothing but a group of computers together. They're acting as one computer. What does that mean? Well, if I go ahead, save a file on one computer and I log into any other computer and I try to read that file, I will be able to read it. Why? Because it's a group of computers together. They act as if they're one computer. What is that? That is your HDFS, guys. Hadoop Distributed File System, alright? And what do we have here? We store data. In here we store different kinds of data. That's all. Different kinds of data is what we have, okay? To read the data in HDFS, what do we have? We have another tool or a framework. That is your MapReduce, guys, okay? So that's your MapReduce. The only way you can read the data is using the MapReduce tool. What will MapReduce do? MapReduce will allow you to read your data, process your data, and analyze your data. But the problem with MapReduce, you need to be an expert in Java. You need to understand how MapReduce works, okay? So HDFS is where the data is. It can be treated as the brain, guys. I have also again referred to this one in our demo session, so please bear with me. In the interest of others, I'm going to repeat some of these things because these are some of the basics, gentlemen and ladies, okay? You can think of HDFS as the brain of Hadoop. Okay, in our brain we store thoughts. Our thoughts is our data, guys, okay? And what do we do with our thoughts? We analyze. How do we analyze? We use our heart. What is the heart? That is the MapReduce. MapReduce is the heart of Hadoop, guys, okay? Then we have a couple of eyes, guys, okay? What do we do with our eyes? Well, one of the eyes eyes of Hadoop is Hive. With our eyes we analyze the world, guys, remember, right? We look at the world with our eyes and we say something is good, something is neutral, and so on. What's that happening? Come here. All right, pass it. So that's what Hive is. What will Hive do? It will take simple SQL as input. Let's go down. It will take SQL as input. It will internally convert SQL to Java MapReduce programs and run on HDFS. All right. Similarly, we have another tool, guys. That is Pig. Let's come here and come here. So there's a Pig. What will Pig do? Pig will take simple English-like scripting statements as input. It will take English-like scripting statements as input, internally convert them to Java MapReduce programs and run on HDFS, guys. That's how Pig works. Those are the two eyes of Hadoop, guys. Okay, and in real world, many times what you will come across is you will come across different kinds of databases. There's your SQL Server, and there's your Oracle database, and let's choose that one for MySQL. And other databases, guys. Okay, many times what people want to do is they want to get the data from these different databases and save it on HDFS. Why? They can use simple tools such as Hive and Pig, and they can analyze their data on Hadoop, guys. Okay, so what do we have? This is where we have another tool called Sqoop. Okay, so what will Sqoop do? Sqoop will go ahead and take simple Linux-like commands as input. It will take simple Linux-like commands as input, convert them to Java MapReduce programs, and transfer the data from from a database to HDFS, which is called import. It can also transfer the data from HDFS and save it to your database, guys. That is called exporting. Okay, but remember, the data in the databases is structured data, guys. Okay, it's referred as structured data. And what's happening today? We have a new database. That's our internet. What do we want to do? Many times companies want to get the data from internet, save it on HDFS, use Hive and Pig to analyze and understand the insights, right? So what do we have? That's where it comes in Flume. Cool. What will Flume do? Flume will get the data from other data sources such as internet sites and other sources, and it is getting unstructured data, guys. It will ingest or it will transfer unstructured data and save it on HDFS. That is what Flume is, guys. Okay, so what do we have here? We have one brain, one heart, two eyes, and a data transfer tool for structured data. Another data transfer tool for unstructured data is what we are looking at. Apart from that, we also have what is called Uzi. Oh, I forgot the stomach, guys. The stomach, there is also something called stomach of HBase, guys. What is that? That's your HBase. HBase is the database of Hadoop, guys. Remember, Hadoop is not a database. What is Hadoop? Hadoop is a distributed file system, all right? And HBase is the database of Hadoop. If you, with Hive and Pig, ladies and gentlemen, we are just analyzing the data. We are never modifying the data. If you want to modify the data, we can use HBase. Again, HBase is the database of Hadoop, guys. And HDFS or Hadoop is a distributed file system. What is a distributed file system? A group of computers together, they are acting as one computer, guys. Okay, am I making sense, guys? Can you give me a quick acknowledgement, please? Okay, cool. So that is the framework of tools. One heart, one brain, two eyes, and a couple of tools for transferring the data. What is Hadoop doing, guys? Hadoop is helping us in running applications on big data. Okay, so what does that mean? If you want to drive a car, you don't have to be a mechanical engineer. If you want to work on big data, you don't have to be an expert in Java, you don't have to be an expert in MapReduce, you don't have to be an expert in multi-process, threading, and all those things. Gentlemen, ladies, shall I move on to the next slide? Cool. And just want to verify, is the pace and everything okay, guys? Are you able to catch up with me? Are you able to follow me? Any suggestions on the pace and things like that? You guys are doing okay, or am I going too fast, too slow, and things like that? Chandra, and how's Sunil doing? I haven't heard much from Sunil here today. Are you angry with us because we started late, buddy? I haven't seen you even typing one letter there, but no complaints, no pressure. It's up to you. The freedom is yours. Feel free to let me know if you have any feedback, okay? All right. Thank you, guys. I appreciate that. So let's move on here. Alright, gentlemen, so Hadoop, it's open source, it's free. The good thing, if it's free, it's much more better for companies, because if it's a commercial tool, there's a lot of paperwork, there's a lot of convincing of upper management to purchase the tools, licensing, and verify the legal aspects and things like that, right? So since it's free, that's also a big advantage for Hadoop is what it is, alright? And move on. So a bit more into the logical architecture of Hadoop, guys, okay? Logically, Hadoop is simply a computing cluster, okay? What's a cluster? A cluster, for now, you can think of it as a group of servers. We'll later talk more about it, about the cluster in the coming up sessions, guys, okay? For now, think of it as a group of servers. So let me go here, come back here. And let's choose that, okay? So what we are looking at is, we are looking at a couple of things from a logical perspective, something called storage and something called execution, guys, okay? The storage, what is the storage? That is your distributed file system. What is this? These are your bunch of computers. Together, they're acting as one distributed file system, guys, okay? So what that means is, if I were to go ahead and save a file in this computer, okay, and I were to log in into this computer, I will not be able to see that from here, guys, okay? But here is the magic. If I were to go ahead and save it in my HDFS, now if I get into this computer and go to my HDFS, I will be able to see that one. That's a distributed file system. There are a bunch of computers there acting as a single storage, okay? On this storage, the data is distributed, guys, okay? So, and we have seen earlier how the 100 MB gets split and distributed. We'll see it one more time. The data is in a distributed fashion, okay? One other important thing, guys, the data is not the only one which is in a distributed fashion. It is the execution, or it is the computation, which is also in a distributed fashion. What will happen? Well, the code will be executed on these distributed parts of your data. It's a distributed computation, guys, okay? These things are pretty complex things to be done, if you were to do it by yourself, but everything is being done by us. These are all the framework level aspects that Hadoop hides from us, and we don't need to worry about it. So what do we call? Hadoop is a computing cluster which provides a storage layer and an execution layer. The storage layer is your HDFS. The execution layer is nothing but your MapReduce. MapReduce will take care of the execution. We'll talk more about that, but that is called the logical architecture, guys, okay? More about the storage layer, HDFS. Let's come here. Cool. Oops, my bad, a little too fast there. All right. Okay. So distributed file system, we just talked about it. A group of computers is what it is. It runs on top of a regular OS file system. So I think okay. So HDFS is installed on top of the native file system. That is what we mean by it sits on top of the regular operating system, and fixed size blocks is 64 MB. Okay. Remember, Anya asked why 64 MB? Well, for performance benefits. If you do not have 64 MB, and we are in the world of big data dealing with lots and lots of data, terabytes and terabytes of data, to read all the data, what will happen is the native files, the native operating systems will have to read lots and lots of small files to put together a 64 MB. Whereas by putting a 64 MB by itself as a simple block, we are able to read it much more faster. That is what it is. That is why it is 64 MB, guys, okay? We can also configure it to 128 MB and 256 MB, which we'll see later. And what does Hadoop do? It will also replicate it. It will also go ahead and save a backup of additional servers, guys, okay? So let me just go ahead and one more time put this here. That's my node 1, that's my node 2, node 3, node 4, node 5. All this group of computers is my cluster, and there's my data. I'm going to put that is 100 megabytes. Let's go ahead and say that is, oops, I just want to explain one more point here, guys. Okay, so that's why I'm redrawing this one. Just bear with me here. Select that. That's 100 megabytes. And what will happen? Hadoop will go and split it. So that is a 64 megabytes. Let's assume, and let's assume that is 36 megabytes, guys. Okay, next it will go and, oops, let's select this one, distribute it. It will save it here. It will also save it here. This is called distribution, guys. Okay, now we are replicating, guys, and here is the point I was trying to communicate. What is that? Well, when I say replicate, I'll go here. Let me replicate the, like that. I'm going to replicate the first block. It's also putting a backup there. It's also putting a backup here, and it is putting a backup of that there, and it's putting a backup of that there. Why is Hadoop doing that? Well, the Hadoop does it because it works on what is called commodity hardware, guys. Okay, commodity hardware is something which can go down at any point of time. Okay, so what does that mean? There is no guarantee on the reliability and the uptime. That is the difference between the enterprise class servers and commodity hardware, guys. So what will happen as a result of that? Our data, if our servers go down, our data on the service is lost. Okay, we do not want to be at a loss of data, right? So that is the reason we are going ahead and replicating it. We keep additional backups of our blocks on other servers. So if one goes down, others will, we can still retrieve the data from others. So the probability of these things of one server going down is higher compared to the probability of multiple servers going down. So that is why we are going ahead and replicating it, guys. Okay, and it is write once, read many times, optimized for streaming in and out. What is streaming? What is optimization? We'll talk a little bit more about that. But it is write once, read many times. What does that mean? Well, here is what it means, guys. Okay, so let's go ahead and write once, take the write once, read many times. It follows the worm philosophy is what you can think. Okay, let's say you upload a video to YouTube. What are we doing? Once we upload it all over the world, we may have multiple friends and relatives. They come to our site, and they view it. So you're uploading the video once. That means you're writing it once, and then it is being watched by many people. When they're watching it, they're reading the file. That is what it really is, guys. Okay, so in HDFS, when we put the data, guys, so if you take this one, when this data is split and distributed, you write it only once, and then you may write a Hive script, you may write a pig script, you may write a Sqoop, or other scripts. What will those do? They will come and they will read this data repeatedly. That is what we mean by write once, read many times, guys. Okay, am I making sense, guys? Can you give me a quick acknowledgement? And Anya says, is there a minimum or maximum number of times one block gets replicated? That depends on us, Anya. Okay, so we can configure that one. We'll see that in the coming up sessions, in the configuration section or session, how we configure and where do we configure, and how to decide on configuring also we will see. Okay, great. Thank you, guys. Thank you. Appreciate that. All right. So that's about the storage layer. Moving on, execution layer, guys. Okay. So here is the execution layer. What is happening? Once our data is split and distributed here. Let me come back here. So once our data is split and distributed, guys, what we do is we go ahead and write different kinds of script. That could be a Hive script, that could be a pig script, that could be a Sqoop, or that could be a Java MapReduce program itself. Okay, so what will happen when you, let me go ahead and choose that one for that. When you write a Hive script, oops, let's go here. When you write a Hive script, guys, what will happen is your code, let's select this one, will move to the place where your data is, and it will execute on your blocks of data. Your code is moving to the data, and what is happening? This is what is called distributed computation. It is taking care of the distributed computation. This is taken care of by your execution layer. That is your MapReduce. We'll talk a little bit more about MapReduce a little later, but let me take a quick question from Chandrasekhar here. He says, what happens if all the commodity servers go down? Good question, Chandra. So if all the commodity servers go down, you'll need to re-upload your data into HDFS, okay? So it's like saying, what happens if my YouTube video where I uploaded, it was completely lost? Well, what will you do? You will go ahead and re-upload your video, right? So in a similar fashion, you can think of it, okay? And Chandra, I hope that helps, buddy. Let me know. And coming back here, the execution layer is responsible for running a job in parallel on many servers. What is a job? Well, when we write a Hive script or a pig script, guys, internally the Java programs are generated. Those Java programs are nothing but jobs. Those jobs will be run in parallel. And remember, writing the code in parallel, taking care of that is also not a simple thing, guys. It is pretty complex thing. Again, Hadoop comes to our rescue. It takes care of that one. That is nothing but your execution layer, guys, okay? It will generate, it is taking care of all the parallelization, whether it is one server, 100 servers, or 1,000 servers and so on, all right? It handles retrying a task that fails, validating complete results. What does that mean? So, because these are commodity servers, guys, let us go ahead, come back here, remove that. What can happen is, when your data is being stored here, this node could go down. Okay, if this node goes down, I have a data backup available. That is called fault tolerance of storage. Okay, another thing also could happen, guys. What is that? The storage is fine, the data is fine, but at the time when the computation is happening, the node goes down. So what will happen? This computation will be executed on another node where the block of data is replicated. Where you have a backup of your block of data, the computation will be executed there. What is that called? That is called fault tolerance of computation. That is what we mean by it handles retrying a task that fails and validating the complete result. So it is taking care. Who is taking care? The execution layer. The MapReduce layer is taking care of that, guys. Okay. Again, the fault tolerance of computation is not easy to write and things like that, guys. It is being taken care of by the Hadoop is what the thing is, all right? And job consists of map and reduce. What is map and reduce? It's a little bit early to talk at this stage. We will definitely look into these things a bit more in the coming up sessions, guys. Okay? But are you guys okay with this slide, guys? Shall I move on to the next one? Cool, great. Okay, gentlemen. So a quick review of how Hadoop is working. Let's go here. So what does Hadoop do? Hadoop will take your data. It is first breaking your data into different pieces. Imagine this as a 256 megabytes file. All right. So come back here. That's your 256 megabytes file. What's Hadoop doing? It splits it in the orders of 64 megabytes. So there's 464's 256. Then it will move the code to the place where the data is sitting, guys. If you come back here, there is my. Okay, so I think I removed that. So let's do a blank. To understand this one, guys, let's take a traditional architecture. In a traditional architecture, you have a database, and let's start with, you have a UI layer, a service layer, and there's your business layer, and there's your data layer, guys, okay? And what happens here is, let's go ahead and also say this is UI, this is my service, this is my business layer, this is my data access layer, and this is my database. What do we do in the database? We will write different kinds of stored procedures and other scripts, okay? Your data will be moved from here to this server, build the data objects, give it to the business layer, apply business rules, then go ahead and give it to the service layer where you're authenticated. Your user ID is authenticated and things like that, and return it to the final UI layer. This is where the user looks at your application and comes at insights, okay? But what is happening here, guys? It is the data. Your code is sitting wherever it is in different servers. It is your data which is moving from one place to another place, okay? So code sits where it is, data moves around, okay? In the world of Hadoop, guys, this is the world of Hadoop. You have lots of servers. Cool. So for the sake of simplicity, Let's assume that. What are we doing here? We'll go ahead and take our data. Okay, we go ahead and, not we, but Hadoop will go ahead and split it. Cool, and then it'll distribute it. Oops. For the sake of simplicity, I'll just go ahead and move one copy. Ooh, 1 second, guys. Okay, I'll keep one block there. I'll select that, and I'll keep one block there. So it distributes your data. Okay, now your data is distributed, guys. What will happen? Well, this is where we have our laptop. Let's take our laptop here again for sake of simplicity. This is our laptop, and what do? Let us say we start writing a Hive or a pig script. To start with, we'll write a Hive script. What will Hive do? Hive will go ahead, it will generate a Java MapReduce program. Okay, then it will move the code to the place where the data is sitting. It will execute it in both the places. What is happening here? Our data is sitting where it is. Okay, but the code is moving to the place where the data is sitting. It is the reverse of what is happening in traditional architectures. That is why we say data is local, code moves around. That is what is called data locality, guys. Okay. Another important reason for data locality, why they move the code to the place where the data is, if this is the size of the code, this is the size of the data. In the world of big data, you deal with a lot of data, guys. Okay. So that is, if that is the size of your data, then this is the size of your code. Okay, if we move this amount of data in our cluster, the amount of network traffic and bandwidth which is involved is very, very huge. So what did they do? They very intelligently reversed it and they move that amount of code to the place where the data is sitting. Cool, guys? Am I making sense? That is what is moving the computation to the data. That is what is moving the, that is what is data locality. Cool. All right, gentlemen, a little bit more, but here's what the plan is. Let's come back here, and we're almost close at break time. So at 8:58, what we'll do is we'll take a short 10-minute break here, and we'll regroup here in 10 minutes, guys. I would like to have a glass of water, and then we'll continue from here. Just stretch yourself and be back. Does that sound like a plan, guys? 9:08. Cool. Thanks, sir. Yes, I'm back here. Can you just give me a quick acknowledgement if you're back, guys? Thank you, Anya. We'll just give a minute here. Chandra, are you back here? Okay, so let's try to make some progress here. So scalable, guys, virtual execution and storage layers span many nodes and scale linearly with cores and disks. Okay, so what happens is, let's go here and take that. So gentlemen, ladies, what we have, there's a node, there's a node, there's a node and a node, guys. Okay, so each node is a server. Each server has multiple CPUs, multiple hard drives, and multiple processors and things like that, guys. Okay, as we increase the number of nodes, our processing power increases, guys. Okay, and why is the processing power increasing? Because our execution capacity is increasing, our storage capacity is increasing, our processing capacity is increasing as we add more number of nodes. That is what we mean by horizontal scalability, guys. Okay, as you add more nodes, you get more power. That is horizontal scalability, and scales linearly. So let's say if I had only one node or server, and we were taking 10 hours of time, cool, to process some data. If you go ahead and use 10 nodes, right, it will reduce to 1 hour. What is that? That is what is called linear scalability. Scales linearly. Okay, that it's almost guaranteed unless you go ahead and unless you have some bandwidth errors or bandwidth problems and things like that, guys. Okay, making sense, guys? Can you give me a quick acknowledgement, please? That is what is linear scalability, and that is virtual execution. They are all acting as if it's a single execution, but they are acting on multiple layers or multiple nodes is what it is. Cool. Thanks, sir. Pardon me. Each block is replicated typically 3 times. Okay, so we discussed about this. The reason we replicate is because they are commodity hardware, guys. So that is how we are achieving reliability. Okay, because commodity hardware can go down anytime, and by having multiple copies, we are making it more reliable. Each task must succeed or the job fails. What does that mean? We will see. Let us say you're starting the car, and what's happening? The fuel needs to be supplied to the engine. If the fuel doesn't supply, then the engine will not start, the car will not drive. Driving a car is a job. What is the task? Your process of supplying the fuel to the engine is the task. Okay, so we'll talk more about jobs and tasks in the coming up sessions. But for now, a job is a collection of tasks is what you can remember, guys. Okay, fault tolerant. Failed tasks are automatically retired. What is a failed task? Again, you know, I'm sorry, retried. I said retired. The failed tasks are retried. As we discussed earlier, we are using a lot of commodity hardware, and these commodity hardware can fail anytime because that is the characteristic of them, and that is why they're inexpensive, guys. Okay, in real world, a commodity hardware is in the range of $5,000, whereas an enterprise class server is in the range of $20,000 to $100,000 and so on. Those are huge. The enterprise class servers give you the guarantee on the reliability and the uptime, whereas the commodity hardware don't. So our task can fail and we can lose our data. So what happens when the tasks fail and we lose the data? Well, automatically Hadoop will go ahead and find the replicas where the data is. It will initiate another task on the replica, and it will also try to make another copy of the replica. Okay, so let's see if we can understand that one here. All right, let's come back here, take a blank. So that's our node, that's second node, that's third node, and fourth node. There's our 100 megabytes file. It's split into 64 megabytes, and let's choose that one, 36. 64 gets saved there, distributed there. Oops. 36 gets distributed there, and then the process of replication for that is happening there, and similarly the process of replication for 64 is happening here, guys. Okay, now pardon me, what will happen is let's assume the server went down. Cool, the server went down. So what will happen? Well, instead of maintaining 3 copies of each block, I only have 2 copies of each block. Let's also, again, for sake of simplicity, assume we have a 5th server. So what will happen? Hadoop will automatically go ahead and work internally and try to make a 3rd copy here for this one, because right now there are only 2. One of the node went down. There are only 2 copies which are live. Okay, and similarly there are 2 copies of this one alive. So what will it do? It will go ahead and make another replica of this one here. So now we have 3 replicas again. It is taking care of balancing the number of replicas, or it is taking care of maintaining the replicas, guys. Okay, that is what we mean by failed data transfers are automatically retried, and failed tasks are automatically retried. It could also be possible when a computation, let's select this one, and cool. When a computation was happening, let us say on this one and this one, what happens? Well, suddenly this node goes down and this node goes down. So what will happen now? The computation will be retried on another node for one block and on another node for another block. This is called fault tolerance of computation, guys. Okay, the tasks are automatically retried. Am I making sense, guys? Okay, thank you. Thank you, guys. Okay, so servers can join and leave the cluster at any time. What does that mean? Well, if something goes down, these are commodity hardware, they fail at any time, so they can go down. They're leaving it. It can happen anytime. What do administrators do? They can unplug this server. They might repair it. They might come back and plug it back in. That is called commissioning the node. The process of adding a node to your cluster is called commissioning, and the process of a server going down and removing it is called decommissioning it, guys. Okay, so these things happen in a cluster is what it means. All right, and so why Hadoop? What is Hadoop doing, guys? What Hadoop is doing is it is reducing the complexity. Let's try to understand that. How is it reducing the complexity? Well, we don't need to understand the complex topics, how they communicate with each other, and how the distributed computation is happening, how the distributed storage is happening, the processing, the threading, and all those things we don't take care. The engine of the Hadoop takes care of that. What is the engine of Hadoop? It's your HDFS and it's your matrices. Those are the two pardon me, sorry about that. Those are the two parts of the aspects of your Hadoop engine which are taking care of all these complexities, guys. Okay, it's a conceptual operating system that spans many CPUs and disks. In other words, it's like another operating system which is sitting on top of a bunch of nodes or a group of computers or a group of nodes, guys. Okay, that's what you can think of that as. And let's move on. Let's discuss a few more things. It is accessible. It runs on large clusters of pardon me. It runs on large clusters of commodity hardware, or you can run it on cloud also. So generally what happens, guys, let's say you get a project in Hadoop and your client says he has about 100 terabytes of data. Okay, let's say we got the project and we want to do this project. What we do is we don't really have to buy 100 servers. What we can do is we can go ahead and rent out these 100 servers on something like Amazon EC2, and then we can test out, do our testing results and things like that. Once everything looks good, we can go back and tell our client, hey, you know, things are looking good, and we use this one. We used Amazon, and we reduce the costs and things like that. Okay, so that is generally, or that is how you can proceed. And once the customers like, then you can on a need-to basis, you can really go ahead and purchase the servers and things like that. Short and sweet, you can use the cloud computing model and try out. You can also use the cloud computing model and try out Hadoop and your data analysis and things like that, guys. That is what we mean by accessible. All right. It is robust, guys. It is architected with the assumption of frequent hardware malfunctions. Okay. So why frequent? Why are we assuming frequent hardware malfunctions? Because they are commodity hardware, guys. Okay. It can gracefully handle. What will it do? It will go ahead and replicate it. You don't have to worry about it. It is gracefully handling, and it is built with that assumption that these servers or nodes can fail anytime. Okay, we'll also discuss more, but that is what it is, guys. Okay, it is scalable. It scales linearly to handle large data by adding more nodes to the cluster. So as you add more nodes, guys, what happens? Your processing power increases and your computation time decreases, guys. Okay, if one node or one service is taking 10 hours, then you can almost be sure by having a 10 node cluster, your computation time will decrease to 1 hour, or by having a 5-node cluster, your computation time will decrease to 2 hours. Am I making sense, guys? Can you give me a quick acknowledgement? You're with me? Pardon me, sorry about that. And it is simple, guys, okay? So Hadoop allows users to quickly write efficient and parallel code. When we write scripts in our Pig, Hive, and Sqoop, what is happening is internally a lot of parallelization, a lot of complex things that we've been discussing are being taken care of by the tools and the Hadoop itself. We don't have to worry about it. You just focus on turning the key to the car. What is the key? Well, key is your Hive, Pig, and Sqoop, and the rest of the tools, guys, okay? And remember, data locality. Here in Hadoop, we move the code to the place where the data is. Why? If the size of the code, if the size of the data is that much, your size of the code is that much, okay? By moving the code to the data, we just involve only that amount of network traffic is involved. Whereas if we move the data to the code, that amount of network traffic is involved. Okay, we cannot run multiple jobs, or it will take a long time. Your bandwidth is completely taken, and you'll run into all kinds of issues which are going to be again unpredictable and complex to handle. Cool. And replication. Oops, my bad. It uses replication across the servers to deal with unreliable storage servers. What is that? Well, it is nothing but it's replicating the data and it takes care of them. That is what it is. Why? Commodity hardware, guys, okay? So these are some of the characteristics from a developer standpoint, why Hadoop, why we need Hadoop, okay? Moving on to from a company standpoint. Let's come here. Pardon me. From a company standpoint, guys, here are the adoption drivers. What is they? Well, bigger the data, higher the value, guys, okay? To understand this, let me ask you a question, guys, okay? Imagine I tell you, Sachin hit a century yesterday, and he's playing another game today, and if I were to ask you to guess if he's going to hit a century or not, what would be your answer, guys? Is it easy, is it tough, or is it very tough? Is it easy, medium, or tough to say whether he's going to hit a century or not? A, B, or C? Just type in your answer there. So question is, Sachin hit a century yesterday. He's playing another game today. And I'm asking you to guess whether he's going to hit a century or not today. Is it easy, or is it medium, or is it tough to guess it? Want to take a shot at it? Is it A, B, or C? Tough, right? True, it is tough, guys, okay? But here is the deal. I will now tell you, Sachin hit 2 straight centuries and he's playing the 3rd game today. Is he going to hit a century or not? Take a guess. The options are A, easy. Is it easy to guess, or is it slightly tough, or is it very tough to guess? A, B, or C? Okay, good. Let's see. I'll give a few seconds here. Is it easy to guess, slightly tough, or very tough? So it's slightly tough, guys, okay? We're still. Okay, let me complete this one, Chandra. I'll come to your question in a minute. And here is another thing, gentlemen and ladies, okay? What is that? Well, Sachin hit straight 9 centuries. He's playing the 10th game today. Now I ask you to guess whether he's going to hit a century or not. Is it easy to guess, or is it tough, or is it very tough? What do you think? Think from a logical standpoint. Okay, cool. Pardon me, sorry about that. So it is easy, guys, okay? Logically, from a common man standpoint, right, what is happening? The more that we know, the more easy, the more possibility, the more the probability. The more the data you have, the more you know about Sachin Tendulkar, the more the data you give about him, the more the confidence, okay? The bigger the data, higher the value. The more the probability, more the possibilities, guys, okay? That is what it makes. And what were companies doing? When they have big data until now, they were throwing away the data. If they have 100 terabytes of data, guys, what they would do is they will just maintain anywhere from 5 to 10 terabytes of data. They will perform analysis on that. So what does that mean? Well, the value they get, the probability or the possibility which will lie inside that will be much lesser. Okay? That is what it means by that. And financial drivers, guys. Today, every company is in a very optimized mode. They don't want to unnecessarily waste money, right? They want to bring down the costs. How? Well, we use commodity hardware and Hadoop is free. That is the one of the most important reasons why everybody is getting into big data. So the amount of cost per terabyte of data will be extremely reduced by a lot, guys. Okay, technical drivers. Existing systems are failing under the growing requirements of 3V. As your volume, as your velocity, as the variety is increasing, guys, what is happening? The complexity of the applications is increasing. Companies are unable to maintain them, okay? Because as the volumes increase, as the servers are increasing, the developers are unable to code and handle them. That's where comes our Hadoop and helps the companies, guys, okay? Gentlemen, ladies, okay on this slide? Anything you want me to repeat, or shall I move on to the next slide? Okay, great. So one more time, guys, we have a group of servers there. They're all Linux-based servers. We are indicating they are low-cost computers. And if you have a file, again, assuming that's a 256 megabyte file, what will Hadoop do? Hadoop will first split it in the orders of 64 megabytes, guys, okay? Then it will distribute it. So we're calling each split as a block. We then distribute it into multiple machines. The problem, they're commodity hardware. At any point of time, one of them can go down for any reason. That is why they call it as commodity. So what does Hadoop do? Hadoop replicates the data. It maintains 3 copies of every block. So at any point of time, if our server goes down, we still have backups of other, we still have backup on other servers, guys. That is what is called protection of the data, or fault tolerance of the data, guys, okay? So that is how Hadoop is working, guys, okay? Making sense, guys, with me on how it is working? By now we have seen a few times, so I hope that is helping, guys. And now let us try to see who is using Hadoop. Okay, so here's a finance in finance domain, how it is being used. How can we protect our company against loss from criminals? That is the question they want to answer. Okay, and what are they doing? Well, it's about fraud detection. There are many kinds of financial fraud, and their securities trading, insurance, and credit card frauds and things like that. Okay, the credit card fraud detection is perhaps the most widely known. Let us say you are somewhere in London. Anya is in London. She makes a transaction. She purchases something in London by going to a store. In about half an hour, imagine she's getting another on her credit card. It appears like there's another transaction happening somewhere in Mumbai. Okay, what will credit card companies do? They are monitoring it. They are detecting such kind of patterns. Okay, Anya is in London. She made a transaction, but again in about half an hour there's another transaction which appears to have been made in another store in Mumbai. Something not right. Okay, so that is what is a credit card fraud detection. Those kind of patterns can be detected, guys. Okay, the specific techniques differ and are proprietary. Every company will have their own techniques, guys, but the common thing, they will have more data. The more the data they have, the more the probability of figuring out the patterns, guys. That is what the thing is. And what do we do in this case? How do we use Hadoop? Well, we can look at all the log data. What companies will do is they look at all the log data, they look at all the data from different databases, get it onto HDFS. Okay, then they'll use machine learning tools and things like that. They'll do a lot of transformations, processing and things like that, and then they give it to the machine learning tools such as Mahout. Okay, those things will figure out the patterns. Okay, it looks like this is something unusual, something not right, so you may want to investigate it. So what happens? Anya will immediately get a call from the credit card company and they'll verify. Hey, you know what? You know, there's a transaction happening in Mumbai, and about half an hour back you appear to have made a transaction in London. What's going on? Is everything okay? Did you really make this transaction? And things like that, right? So that's an example of how we can use the credit card fraud detection, guys. Okay, am I making sense, guys? Pardon me. Okay, thank you, guys. We'll move on here. So there's the retail. Which products will this customer enjoy? You know, how do you know? When you go to Amazon, right? Let's say you're searching on a book called Hadoop. You'll see a bunch of recommendations coming up saying that you might be interested in Hadoop in Action, Hadoop in Definitive Guide, and so on. Okay, so that's what we mean by which products the customers enjoy. So here is an example. Sites use collaborative filtering to suggest products. Okay, collaborative filtering means when you are looking at a particular product, you might be interested in other things. How do you know that? Well, if you have the data, what other customers who looked at this particular product also were interested in, doing that kind of analysis is what is called collaborative filtering, guys. Okay, it will help you in increasing the sales, attracting customers, and improve their satisfaction, because sometimes customers may not know. They're looking at Nike shoes. You also present them Nike, Reebok, and Puma. They might feel happy about it that you have recommending. They may not know about Reebok and Puma, or vice versa, right? So that will improve their satisfaction. And also, if you go to Amazon or Netflix, right? Amazon is where you purchase different kinds of books, videos, and other kinds of things, right? Netflix is a site where you order, videos, DVDs and things like that. You can rent them, they will mail it to you. So if you were to go to their website and you were to browse one of the DVD, they will go ahead and show you a bunch of recommendations. How do you do that? Well, again, that's where Hadoop and big data comes in. And last.fm is about the music side. You might be interested in a particular song or writers and things like that. When you're browsing, a lot of other recommendations could be shown, and that is how it helps, guys. Okay, so collaborative filtering has many such applications. The concept can be applied in many other domains also, guys. So what would you do from a Hadoop perspective? You will capture the customer activity and preference data. The more the data you have, the more better it is, guys. The more the probability you will get out of that, all right? And you will try to find the customers with similar preferences, the other customers who have shopped for similar kinds of things, and the other customers, who have similar patterns, clickstream patterns and things like that. You can look for them. You can compare those patterns, okay? And then what do? You find which products these customers rated highly, or these customers might be interested in, and start recommending them. Okay, making sense, guys? That's a scenario in retail is what it is. Cool. Care for an acknowledgement, guys? Cool, great, appreciate that. Okay, so advertising, how can we make our advertisement more relevant to the user? You're looking for Nike shoes? Well, I got Reebok and Puma, slightly more cheaper, almost the quality is the same. How would you like that? Well, we're spending more money. We're spending less money. We're getting almost the same quality. Maybe a good choice, right? And these days, if you go to Google or anywhere and you search for Nike shoes, you get different kinds of ads. What is that? How are those ads being shown? Well, that is the scenario of the advertisement domain, guys. Okay, it is a significant source of revenue for web advertisements and things like that, because a lot of recommendations, that's where you can find out who are the other users who are interested in your products and company and things like that. How do you do that? Well, pay-per-click is much more valuable than pay-per-impression. So pay-per-click, these days, as you click on the ads, sometimes there are these plans where Google will pay you a certain amount of money if there are so many clicks and things coming from your site and so on. Those are pay-per-clicks, guys. Okay, you can boost your revenue. The more the clicks you get, the more the chance of probability or the possibility of making more money, because more visitors will come to your site, and more visitors come in, the more the possibility of making a purchase, and as a result of that, your revenue will increase, guys. That's what we mean by that. Okay, machine learning techniques are common. So what generally happens is, we take all this data, we pre-process, we process them, and we transform them into various kinds of things. How do you do that? That's where you will use Hive, Pig, and things like that, guys. Okay, and then you feed it to machine learning tools such as Mahout. What Mahout will do is, it will allow you to go ahead and run these machine learning algorithms using Java MapReduce, and it will allow you to detect some patterns. You'll understand the patterns of that, guys. Okay, so data typically analyzed includes relevance of the ads, overall historical effectiveness of a given ad, time of the day, day of the week, and things like that. These are some of the parameters that you will use to figure out the patterns and things like that that the other customers on similar days of the week, similar times of the week have been doing, and other things, guys. Okay, all these factors are independent of the user. Whether you're an Indian user or another user in another part of the world, they do not depend on, they may not depend on your nationality, or they may depend on the nationality also, guys, okay? They can be dependent or independent of, any of the variables of the data that you have. Again, I'm going slightly deep into that. You don't need to be understand every word that I'm speaking out here, but just giving you an idea, guys, okay? So let's see from a Hadoop standpoint. We want to predict what an average person would click. That is, we can do predictive analytics using Hadoop. Collaborative filtering again, okay, comes to rescue. What others have clicked on, what others have used and looked at is what we can compare, and we can find out patterns. And this technique increased Yahoo's prediction accuracy by 10%. A prediction accuracy of 10% is pretty good, guys, in the world of predictive analytics, okay? Am I making sense, guys? Slightly deep here, but that is just a I'm just giving a quick idea. Again, you don't need to understand every word, guys. As long as I'm giving you a high level idea, that should be enough. Cool. Care for an acknowledgement, guys? Thank you, guys. Okay, and then comes the telecommunications and utilities. Okay, how can we actively prevent service outages instead of simply reaching to them? So today what companies want to do is they do not want to wait for a problem to occur. They somehow want to predict if a problem is going to occur, and they want to proactively take care of, guys. Okay, telecommunications, they use a lot of infrastructure. If there is somehow they're able to predict, hey, a particular equipment is going to fail, right? Then that is going to be pretty helpful. They can immediately go ahead and take care of that even before it fails and save costs and things like that, guys. Okay, so that is what is predictive analytics, or predicting equipment failure. Power, water, telecom, all these are utilities, and they're used in almost all the locations, right? Too expensive to replace components that still work. They are expensive, and cost of failure can be very expensive. Okay, so what do we want to do? We want to install sensors and gather data. Almost everyone is doing this, guys, and these sensors generate huge amounts of data almost on a millisecond basis. They are generating the data, guys. What do? That's a lot of data. We can use Flume, store the data in Hadoop, analyze using Pig and Hive, see if we are able to find patterns of failure, and by using machine learning techniques and others, and replace them before they fail, proactively, in a proactive manner, guys. What will happen? We will save a lot of money. Okay, and customers will not be happy because something has failed and you do not have, and that's a very important thing for businesses, guys. Okay, so that's about the telecommunications things, guys. Okay, bit more on pharmaceutical. How can we protect patients from dangerous drug interactions? Okay, what is happening today, guys? If you go to any of the hospitals today, what they're doing is, as they ask you to take some of the tests, right? Your tests, after they take them, they are today becoming capable of comparing it with millions and millions of other patients worldwide. Why? That's big data. Big data is easily enabling them. And what is happening? They are finding patterns. What did this kind of patients who came earlier, when they took this kind of a treatment, what happened to them, and what were the things which were done? By comparing those things, right, what will happen is they can come back to you and they can predict something which is going to happen to you. Let's say you have a cold, and it looks like all the people who have cold are immediately catching fever. By analyzing that one, they'll immediately call you, and let's say you got in there saying you have a cold, they'll also ask you to take some tests for fever. What are they doing? They are proactively detecting, taking some additional precautions to see if you have more possibility of getting a fever, and they'll go ahead and try to deal with it even before you get that. Instead of cold and fever, you think it's like some more serious disease. That is very useful for the patients, guys. If you're able to help the patients or save the patients from getting some serious diseases, that is very that's not an ordinary thing. Short and sweet. Okay, so that is about that. More accurate medical reconciliation. A physician needs to know what medicine the patient uses. Drugs can negate one another or cause deadly interactions. So if some medicines are being used and they're having some reverse effects or negative effects, by comparing, the more they compare, the more the analysis they do, right, they will be able to get some useful insights. Whether they should give this kind of medicines or not in the future is what they can understand, right? And this data is not always accurate. So what do? Some patients may not recall all medications when asked. Others might intentionally omit others. And a study documented discrepancies in 80% of the patients. Okay, so we do not have very accurate data. Okay, so what? Well, similar to product recommendations. So what do? Because you do not have this very accurate data, by doing the comparisons with others, you will be able to, it will help you in recommending what are all the other medicines which have worked successfully for similar patients. It's like recommending a product to a customer in a retail domain, guys. Okay, the concept is same, but the domains are different. Okay, so the result is a list of medications that similar patients report, and physician can then specifically ask about a test or for use of these and so on. Or in other words, he is able to recommend, he is able to, without really opening up their privacy issues, they can go ahead and take care of the patients in a much better way. That is what the idea here, guys. Okay, gentlemen, ladies, am I making sense? Okay, guys, thank you. Okay, so let's move on here. So, okay, now let's try to understand one of the commodity hardware specifications and things like that, guys. Okay, let me come back here, just adjust my screen. Oops, where did that go? Okay, there you go. It's been hiding from me. All right. So let's look at a commodity hardware, guys. Typically, how a commodity hardware will look like. Well, a 2 quad-core processor, about 24 GB of RAM. In certain cases, I've even noticed much lesser RAM. It's not a must that it has 24 GB, but in a production environment, generally anywhere from 16 to GB is what I've seen. And this is from a pardon me. Pardon me, guys. Sorry about that. And this is from production standpoint that we are indicating here. What we have is we have 12 times 1 terabyte SATA disk. Okay. So what that means is, imagine this is a commodity hardware. You can have, imagine you have, that's one hard drive, that's a second hard drive, that's a third hard drive, and so on, up to 12 hard drives. So each hard drive is 1 terabyte. Okay, they could be SATA disks or the normal disks also. SATA is slightly more faster, and about 12 hard drives is what we can have. We can have 1, or we can have up to 12 or more also, but typically about 12 is what we have indicated here, and they are JBOD. Okay, so let's say I have 12 here, and I go ahead and start plugging in 10 more tomorrow. Okay, all these things, the space on all these hard drives will be getting contributed to HDFS. Okay, what is that? As I add a disk, it is becoming part of the HDFS. What is that? That is JBOD. JBOD means just a bunch of disks. These are all nothing but just a bunch of disks, guys. Okay, that is what it means, and no need for RAID. What is RAID? Typically, in an enterprise class server, guys, if you have a hard drive, what you will also have is a secondary hard drive. Okay, so what happens is, as you put any data onto your primary hard drive, it will internally get saved onto your secondary hard drive. It is internally doing the replication on the secondary hard drive, but this is much slower. Okay, and this is very expensive, guys. That is what is called RAID. Redundant array of independent disks is what they call it. Okay, this is not needed in a secondary, in a commodity hardware, is what we are saying, because if that comes in, it increases the cost. All right, and generally they are about connected by a 1 gigabyte of bandwidth speed is what it is. They're in the range of $5,000 is what it is, guys. Okay, now let's see how do you calculate the HDFS space, guys. Okay, imagine that's our 3 nodes in a cluster. and we'll go ahead and, for the sake of simplicity, let's assume we'll go ahead and put a 64 MB file in this one, guys. Okay, if I try to put a 64 MB, there will be, it will go ahead and get saved, then it will get replicated. Okay, step one is it will save on one node, then it will get replicated there, and it will get replicated there, guys. Okay, so now what is happening is, a 64 MB will become 64 plus 64, 128 plus 64. That's going to be 132, 192 megabytes. Okay, so after the replication, our total space becomes 192 MB for any unit of data, guys. If this was 1 terabyte of data, that means it will become 3 terabytes of data in my HDFS. You might be asking me, because our data is becoming more, and won't we be using more servers and things like that? Even in such a case, guys, our overall cost will be much lesser compared to a traditional architecture or traditional way of doing the things of using the enterprise class server. Even then, our cost will end up being lower, is what it is. All right. So the important thing is here, our 1 terabyte becomes 3 terabytes is what it becomes, and then an additional 25% of the 3 terabytes is what we need to take, and we need to save it for temporary processing, guys. Okay, so we need to consider 25% of, let's say, 1 terabyte is 0.25 terabytes. That much needs to be considered for additional processing. That is what, that is how you compute the effective HDFS. 1 second, guys. Sorry about the pause, guys. My apologies. So let me come back here. Okay. So that is how we calculate the effective HDFS space, guys. Okay. So here what we are taking is, for a moment, let's assume we have about 12 terabytes of data coming into our cluster. Okay. The way we need to calculate how much of cluster space we need to have. This is just a brief introduction. We'll talk a little bit more detail how we go about that in the coming up sessions, guys. Okay. What we need to do is, here's what we need to do. With replication, if I put 12 terabytes of data into my cluster, it will become 36, guys. Okay. So 3-way replication leads to 3 terabytes effective HDFS space. So if I put 12 terabytes, it becomes 36, guys. Okay. Generally about 1/4 of 36 terabytes, 1/4 of your total space is reserved for what is called shuffling. Shuffling is for temporary processing and things like that when MapReduce jobs run, guys. Okay. So what does that mean? Of 1/4 of 36 will become 9 terabytes. All right. So what are we looking at? Not only should I have 36 terabytes for replication, but we should also have an additional 9 terabytes for additional temporary processing. That means 36 plus 9, 45 terabytes, guys. Okay. If you apply compression on that, with a 7 times compression, we are looking at a 20 terabyte per node cluster, or we are looking at about 20 terabytes of total cluster capacity is what we need to have to store 12 terabytes of data with a replication factor of 3. Am I making sense, guys? Can you give me a quick acknowledgement? Okay. And what else we have? Well, from a cost perspective, it is about $250 per terabyte if you use commodity hardware, whereas if you use enterprise class hardware, it will range anywhere from $5,000 to $100,000 per terabyte per user terabyte of data, guys. Okay, that is what we are indicating, and that's what is causing, or that's what is drawing the attention of everyone into the world of big data. That is one of the main reasons, because they can lower the cost by using commodity hardware and perform some rich analytics using big data, and which will be helpful and useful to the companies, guys. Okay. So moving on, a few differences between RDBMS and, let's go down, to the RDBMS and Hadoop, guys. So let's try to look at them. RDBMS is structured, guys. Okay, structured means you say you have a table. Well, you'll know everything about the table, the parent, the child, the relationship, constraints, and things like that. Generally, in a transactional world, you design all these things, you design your table ahead, and then you go ahead and save the data, right? So that is what is structured data. You know the scheme of it. In the world of Hadoop, you need not know the schema. You can just plug in the data into Hadoop without really knowing any schema. You can store any kinds of data, guys. Okay, RDBMS is generally limited. Okay, and no data processing. You don't try to put all the data into RDBMS. If you try to design it, you try to eliminate most of the data and put only those parts of the data which you think are important. But it could be possible what might be important, what might be unimportant today might become important tomorrow. In such case, you have lost that. You have archived it, and it's going to be a big deal to retrieve the data, or you might have lost it. That is what we mean by limited, guys. So as a result of that, we are not processing that data. We are doing limited processing. Okay, in the world of Hadoop, there is no limit. You can put any amount of data, and the cost will not be very high because of commodity hardware, and processing is coupled with data. Remember our data locality, guys? Our computation moves to the place where the data is sitting. That is what data locality is. Okay, and then in RDBMS, the governance, it's all governed. Your standards and the rest of the things are you design everything. You have your governance done first. Okay, in Hadoop, it is loosely structured. You do not need to design your data. You can just put your data, and later, based on the use cases that you work, you can go ahead and do the design on a use case basis. All right, that's what we mean by loosely structured. Okay, it is required on write. What is that? Well, schema. Again, if you want to, let's say you have a table like this, guys. Okay, take a table called customer, and say you have an ID and a name. And let's assume for a moment in name you can store up to 50 characters, okay? But what happens at the time of saving the row? You go ahead and save an ID and a name, you specify 51 characters. What will database do? Database will not save it. It will complain. I cannot save this row because I can only accept 50 characters. What is that? You are verifying the schema at the time of writing. Cool. What does Hadoop do? It will not verify that kind of data, or it will not do that. You do not have to do that kind of validation checks. Okay, you can save any kind of data. You do not have to validate it first, and then again, based on the use cases that you're working, right, what you do is you go back to the saved data. Once you save the data in Hadoop, you will go back. See if I can select that. You will go back to your data in your Hadoop, and at that time you will verify. When you're reading the data, you will verify, do I have 50 characters, 51 characters, or you might apply other business rules. What are we doing? We are verifying the schema at the time of reading. That is what schema on read means. Okay, and reads are fast. Why? Because in RDBMS you deal with much smaller amounts of data, guys. Okay, and in Hadoop, writes are fast. Why? At the time of writing, you're not verifying anything, so writes will be much more faster. If you want to save 1 billion rows compared to RDBMS, Hadoop is in RDBMS there will be 1 billion verifications. In Hadoop you're not verifying, so writes will be faster here. And another important thing is we are dealing with big data, guys. So when you're reading, it's not necessarily that fast as an RDBMS. Okay, am I making sense, guys? Can you give me a quick acknowledgement? Cool, great, appreciate that, guys. Appreciate your diligence there. So let's move on to the next one. Okay, RDBMS, they're costly, guys. They're not cheaper. And in Hadoop, it's free. And there are a few companies such as Cloudera where you can purchase the support. Okay, they provide their own distribution of the software. You can purchase just the support, and rest of them is free. Cool. And in RDBMS, your tables, everything is designed first. You know your tables and entities. Okay, that's what a known entity is. And in Hadoop, you do not have to design, you do not have to know it. Okay, you can put anything, and their complexity will grow. They can increase, but you don't have to care, or you don't have to worry about it. It's just based on your requirements. At a later point, you will go ahead and redesign them. Okay, that is what we mean by that one. RDBMS is used in OLTP and OLAP. It is used in transactional world primarily, and you can also do the analysis on that, but generally it is limited to, you know, rather small amount of data compared to Hadoop. You cannot really do analysis on big amount of data, guys, okay? And but it is more fit to use for operational data store, which is nothing but transactions and things like that, okay? In Hadoop, it's about discovering. You do a lot of data discovery, you do a lot of processing of structured, unstructured data, and you do a lot of massive parallel processing and things like that, okay? That's what it is. And what do you get? You get insights. You understand some very useful patterns in a easy and simple way. May not necessarily be an easy and a simple way, but you will be able to discover some patterns which will be very useful and helpful for your companies, guys, okay? So that is what it is about, okay? Any questions on this slide, guys? Shall I move on to the next one? Great. Thank you. Appreciate it, guys, okay? So these are the different projects, guys, we have discussed, and let me see if I can quickly put them like this. Well, that's our brain, that's our heart, that's one eye, that's another eye, and that's our stomach. That's a workflow scheduling tool. This is used for transferring the data, structured data into HDFS, and this is used for transferring unstructured data into HDFS, guys, okay? Mahout, okay, this is not part of all these things are part of our course, guys. Mahout is not part of the course. Mahout is another machine learning library. It's a Java machine learning library which will allow us to run the machine learning algorithms natively on MapReduce, guys, okay? So it's used at a later point. We do a lot of transformations and things like that using all these tools, and then we feed the final output to Mahout. Mahout is one which will apply the machine learning algorithms, is what it is, guys, okay? So roughly, so here's a slightly more formal definition. Flume, a distributed service for collecting, aggregating, and moving large amounts of log data. So let's say you want to get the tweets from Twitter or maybe any other additional servers, you can configure Flume and get all that kind of data. Once you get that kind of data, we will use Pig and Hive to analyze the data, guys, okay? What will it do? It has a simple and a flexible architecture based on streaming data flow, okay? So in other words, you can actually write a program for what Flume does, but what will happen is you will again unnecessarily have to write a lot of complex things, and that is what Flume hides for us, okay? It will take care of that. It is robust and fault tolerant. It will also provide it will sit on top of HDFS, and we will automatically inherit all the good things of HDFS, guys, okay? It uses a simple extensible data model that allows for online analytical applications. So it's an extensible model. If you want, you can go ahead and write your own classes and build your own way of getting the data for your own analysis and things like that. That is what Flume is, guys. Hive, it is called a data warehouse, guys, a data warehouse infrastructure built on top of Hadoop. Again, it sits on top of, actually MapReduce is what it sits on top of, and it allows us to do the data summarization, querying, and analysis is what it is. It is one of the eyes, guys, okay? That's what we mean. We use the eyes for analysis. And there's a stomach, the database of Hadoop, guys, okay? It is coming out of the Google's big table, written in Java, and HBase is mostly being used from a Java perspective rather than from a Hadoop developer perspective, guys, okay? That has been my observation. That may not be 100%. It may not be 100% right in all the cases, okay? And Mahout, it's a scalable machine learning algorithms, okay? There are a lot of tools which provide the machine learning algorithms and things like that, guys. But the problem with them is they'll work on one computer. As your data grows as your data sits on multiple nodes or servers, right, they will fail. That's where Mahout comes. It is scalable. No matter how big your data is, it can run those machine learning algorithms without any problem, guys, okay? And recommendations and some of the earlier use cases that we have seen is a quick, example of what are all the algorithms do and things like that. Okay, here's one more eye. It's the high-level platform for creating MapReduce programs using language called Pig Latin. So this is another I use for analysis. It's called a high-level data flow language, guys. Okay, when we use Hive and Pig, gentlemen and ladies, actually when we use Hive, Pig, Sqoop, Sqoop, and or Sqoop, right? You don't focus in terms of Java or MapReduce. You think in terms of data mostly. Your focus is on the data. Okay, you do not think in terms of how the Hadoop works. So that is what they free us. They hide all those things from us, and we give simple English-like commands as input for Pig. It will internally take that and convert them to Java MapReduce programs, guys. Okay, if you're familiar with SQL, you know Hive will be very natural to you, and if SQL is not a must, okay, but still we're saying it will be natural to you, because it is almost same. And Pig is also very similar to SQL, guys. It's just that it will use different kinds of terms and terminology when we are working on that. Okay, Ooze is a workflow scheduling tool. We will generally want to run a Hive script and get the output, feed it to Pig, and then run it, feed it to Sqoop and things like that. So Ooze will allow us to schedule such a workflow. Okay, so we'll be covering this one later towards the end. And Sqoop is a tool for data transferring the data from databases into HDFS, guys. Okay, that is what Sqoop is about. And that is the end of the first module, gentlemen. Cool, gentlemen and ladies. How are you guys doing that? Do you find it helpful, guys? Any questions? You can feel free to let me know at this point. If you want to come on air and if you want to ask any additional questions and things like that, feel free to let me know. You can also ask them later. Chandra is from our kernel point of contact. So I think there you go. He sent a mail to everyone. The registered students share their comfortable time for installing Hadoop in their laptop. Please mail us back with team your user ID and password. Okay, and there's his email. So just stay in touch with him. If you get any questions later, you can feel free to get in touch with them. Anya, my plan is I will explain both version 1.2 and version 2.2 Hadoop version. Anya, okay. Great. And have you found this useful, guys? Is that useful? Do you feel any better? Does that kind of give you an idea of what is Hadoop and to get started with? And or in other words, do you like what you've seen today? Okay, sorry about that, Chandra. I'll put you on air here. Chandra has a question. Chandra, you're on air, buddy.
Yeah, the session was very good. Thank you for that.
Appreciate
basically, as I said, thank you, Paul. Basically, as I said, I'm the background of middleware. I know the Java and SQL, but I'm not that much expert in that. How will it be if I learn this thing, and will I be able to cope up with the things?
Absolutely, Chandra. Hadoop internally uses very sophisticated concepts, but you don't have to be a master of all those concepts. You just need to have an idea about it, okay? From a syntactical perspective, the Pig, Hive, and Sqoop and all these things is what you will focus on. And these are not very difficult things to learn, okay? Because you're already into the middleware. Sqoop is kind of your middleware here, and Pig and Hive will also will not be very complex, okay? And Ooze is also going to be your cup of tea, because that is how you schedule a lot of workflows and things like that. But even companies, according to my understanding, in a recent article that I have read, Chandra, somewhere in New York or New Jersey, a pharmaceutical university has started training their students on Hadoop because they have lots of data to analyze and things like that. Okay, you can just imagine if people who are coming from medicine background are learning Hadoop, you coming from a background of middleware, that's a pretty sophisticated background. just imagine if you will not be able to learn what they will be able to learn, Chandra. Okay, so that is one perspective. I can give multiple perspectives, but let me know if that helps, Chandra.
Yeah, it's fine. I got your point.
Good, Chandra. I appreciate that. Any other questions, Chandra? And about the content, just in case you're wondering what's the next plan, tomorrow we will try to focus on understanding Hadoop cluster. So let me go here. And there's my module 2. So these are the things that I intend to take for tomorrow. We'll focus on how the workflow of Hadoop, what is the workflow of Hadoop, and what's the different things which go on Hadoop, and we'll try to get familiar with our virtual machine. And in a day or two, once some of the formalities are done, we will also ship out allow you a place where you can download our virtual machine. I have everything installed there. So that is what I'll give you an overview. And we'll try to discuss how do you design a cluster, how do you plan on designing a cluster, what is rack awareness, and how do you go about choosing the right software and hardware. Okay, that's going to be the part of module 2. And then the next week we'll get into map reduce and advanced map reduce concepts, and followed by what is again a bit more on Hadoop 2.0 and yarn, and also how do you design a cluster. We will continue on that. That is going to be the plan for the next week, and those will be the rest of the week's sessions, guys. Okay. Anya says, would you be covering the admin in depth? Okay, so it depends, Anya. It depends on what you would be registered for. So if you're registered for admin, yes, I will also go into admin in depth and give you a good idea of all the possibilities that you might come across in admin world. Okay. Great. Any other questions, guys? Sunil, I haven't heard a lot from you. I do not know if you do not intend to, or if you do not have any questions, but feel free to let me know if you have any questions. Okay. Cool. Okay. Great. So, gentlemen, ladies, if you do not have any questions, we can go ahead and wrap it up here for today, and we can we'll meet tomorrow. Does it sound like a plan, guys? Very good. Great. I appreciate that. Okay. Thank you. So look forward to meeting you guys tomorrow. You guys take care. Have a good weekend, and I'll look forward to meeting you tomorrow. And that's it, guys. Bye for now. Okay. Talk to you later. You can sign off, and I will go ahead and give my control to Chandra at Kernel. Okay, Chandra, you can take back the control. I'm gonna stop the recording here, Chandra.